Okay, guys, we are recording. Let's go. Okay, for the vocabulary at the top. I'm not making you write these today. I typed them in for you. We're going to talk about them. I want you to process it. We have an image, and we have a pre-image. The pre-image is our original orange triangle that we have. The image is whatever we did to it, whatever came next, when I rotated it, when I flipped it, okay? So the image is our new figure. That makes brain sense, right? A pre-image and then an image? Okay, cool. Transformation. Anything that moves it. We just did 4 of those in Desmos. Okay, we're all done with computers now. And let's see who was listening. Isometry. What did it mean? Alan. Right. Everything stays the same. Our side lengths and our angles do not change. So the image and the pre-image are congruent to one another. They're exactly the same size. Daniel, computer. Oh. All right. Moving on. This is going to go pretty quickly, because we've already done it. We did it by hand, so we don't have to write as much. The pre-image is reflected over a line that acts like a mirror. Reflections. The image is turned about a fixed point, so what would that be? Rotations. Good. The pre-image is slid. Translation. So people get those confused because transformations are all of them. We're transforming the pre-image into a new image. But translation means slide, okay? All right, pre-image is enlarged or reduced. Dilations. Good. All right, and then you fill in this blank. Which one is not in isometry? Dilation. There we go. Good job. Okie dokie. Is this in A? Is this isometry? No. No. B? C. Yes. C? CC. Yes. So all it means is the exact same size. Isometry is a very easy concept to understand. The word itself is not easy for kids to remember. So that's why I'm trying to say it as much as possible today. Okay? So here's a weird little way to remember it. You ready? I so me. I'm still me. I so me. I didn't change sizes. I didn't do anything. I so me. I so me. Try to change me, but you can't. Okay? Here we go. I so me. Okay, here we go. Here's the very first time I'll say this, and then you'll hear it for the rest of the year in geometry. When we have the name of a triangle, this is the symbol for triangle, guys. What?
It's a triangle.
Triangle. What?
I don't know if it changed them.
Oh.
Yeah, isn't it?
It is when we're doing algebra. And in geometry, this means triangle. Triangle JKL. When we write a triangle, and it's mapped onto another triangle, meaning they're congruent to one another, angle J will go with angle M. We write them in the order in which they match. Angle K would be with angle N, and angle L would be with angle P. Does that make sense? Makes brain sense, right? So we can also do that with the sides. So the side JK, that segment, would match up to MN, and so forth, okay? All right. This mapping is a reflection, therefore it's an isometry, so nothing changed about the shape. Given that it's an isometry, find the length. So what is the length of NP? Boom, so smart. What would angle M equal? So smart. So smart. Not bad, right? Okay, moving on. On the bottom, The translation. So slide a figure without changing the orientation. So we don't rotate it. We don't do any of that. We just slide it. And it is a what? I keep doing it. Isometry. Isome. Try to change me. I can't. Isome. Okay. Yeah. All right, coordinate. Don't turn the page yet. I want to write something down here because it accidentally printed on the other page and I don't like that. Coordinate notation is how you'll be expected to describe translation. So translation is a slide, okay? So x, y. Any shape that we have, each vertex will have a coordinate point. And when we slide it, we tell it what to do. So x will be either plus or minus some number. And then y will be plus or minus some number. Easy enough, right? That is our coordinate notation. Now when you turn the page, you'll see that at the top, but disregard it. We already did it. All right, let's do this one together. Example 3. Here, look. We just talked about this. Coordinate notation. So we have the original pre-image, ABC. The image, we know this is the one that has been moved because of these tick marks. So this was original A and this is A prime. That's what we call it. Original B, B prime. Original C, C prime. If I did another triangle, it would be double prime. A with 2 marks and so forth. So they're telling me shift each point 4 units to the right. Because it says x plus 4. And 5 units what? Down. So here are my original coordinate points. I could just do the math and write in the new points and then plot them. I could read the new points off the graph, whatever I want to do. But for this one, A prime is x plus 4, so 7. Y minus 5, negative 2. That's me doing it with math. Or I could have gone over here and I could have read that coordinate point. All right, fill in B and C. All good? Why not? What's wrong? Okay. All right, example 4. I'm going to help you find A, B, and C, and then you're doing the rest. Okay? A is currently located at negative 2, positive 5. So I am looking at my pre-image right here. B is located at 3, 0. And C is where?
1, negative 3.
Perfect. Now you are going to find this image and draw it. And your second one. Go.
Oh, I get it. -5 million. Sorry. I think it's darker. So the white place again. Wait, what the heck was it? Guys, you stop. I just realized how weird you are.
You just realized?
You are.
Quiet.
Oh.
Oh, so you wanted that. I'm just being messy. Ready to practice?
Yes.
What was that?
All right, check it out. See how you did.
Mine is not straight. Why is it not?
I tried to color coordinate it so you can check easier. Yeah.
I think a little more than A.
So we always start at the pre-image. Yep. Yep. There will be specific instructions if they want you to start from your new image. It'll say using your newly created image, translate. Yes. You're welcome. Yeah.
Yeah, I'm
Okay. Does anyone need anything for that one? Are we okay? All right. At the bottom, you are given the pre-image and the image. You have to write the coordinate rule that happened. So from X, Y, what happened? So see if you can figure that out. Write your rule. Write your rule. What did they do to translate this pre-image to the new image?
Right is positive. What? I got X plus 2. Y minus. Wait, I missed the.
All right, all good? Questions, problems?
Oh yeah, just 5.
Pretty easy? All right, good, good. Let's do one more thing before lunch. Flip over. All right, last one for translations. Find the coordinates of the pre-image of the point, so only one point. Do you like my nice straight line? I was looking at you guys. All right. This is the new point. We're trying to find out what did it used to be. They asked me to find the pre-image. So whatever X we did have, they had subtracted 7 to get 5. So what number minus 7 would have given me 5?
13.
12.
Oh, 13.
And what number plus 6 would have given me 2?
Negative 4.
There you go.
So
There we go. Wait, what? We're finding the pre-image. We're not taking this and doing that. This has already been done. We're going backwards to find the original. Yeah. That's why I pointed the pre-image there. All right, reflections. A reflection. And we know this too. It's not going to be hard. Is a flip over a line. These two figures will be mirror images. So not isometries, right?
Wait, no. Yes, I saw it.
Yes, isometries. Trying to mess with you. Trying to mess with you. The mirror line is the line of reflection. And then a figure can have a line of symmetry, as we know, if it can be folded over and you have the same thing on top of the other side. I don't know what I'm writing, do you? Yay! Okay. So I'm going to give you a little bit of a disclaimer. Every single year, some kids are just geniuses at lines of symmetry, and some kids, me included, really struggle with lines of symmetry because I always want there to be more than there actually are. Today will be the day if you find out you're a genius at a line of symmetry, or you're more like me when it comes to line of symmetry and you kind of struggle with this. It's not hard because we have 1, 2. So this one has 1, 2.
Well, that can't you just keep going like this one?
Nope, so you're like me.
Wait, why can't you do that?
On this one, if you folded it that way, it wouldn't be the same.
Oh, yeah.
Alright, B. Does anyone have an idea how many, Alan?
5.
Okay, Alan says 5. I agree on that one. So we can fold it right here. Hey, here's a pro tip. Number your lines as you go when you're doing lines of symmetry because it's very easy to lose track. 2. I can fold it there. 3.
How much was this? 60. Oh, what? Wait, what's that?
4. 5. This one has 5.
Oh, I get it. I get it. I understand it.
Okay. So if you got it with that one, great. But they get harder. Alright, C. See if you can take a minute to determine how many lines of symmetry C would have.
Like infinite. I see multiple ones.
So try. I could definitely fold it here, so that's 1. Well, that's on the recording.
You can do 4.
I can do here, so 2.
It's not 4 all together.
3.
Oh, I forgot about
No, wait.
Alright guys, do you hear my voice? Do you understand now why it's important to number as you go? Because the question will then be how many lines are there, and a lot of people will keep counting. Okay, you don't want to count the same line twice. So number as you go. As you're drawing, always draw completely through the shape so that you can see the entire line, okay? Alright, what about D? How many?
1.
Just 1, good job. 1. E? None. F? 2, that's right. And this is one that people will argue. I guess it's lunchtime. Bye.
I am not a genius at line